Close your eyes for a moment and imagine standing in a snowstorm. Not the kind that chills your skin, but one so gentle, so constant, that it has been falling for millions of years without pause. Now imagine this snow is not frozen water, but the remnants of life itself, drifting downward through an ocean of darkness. What if I told you that right now, at this very moment, trillions of particles are silently descending through the deep sea, carrying the story of the surface world down into the abyss? This is marine snow, and tonight, you and I are going to follow it all the way to the bottom of the world. Our journey begins at the very top of the ocean, where sunlight still penetrates and life thrives in abundance. Here in the euphotic zone, the upper 200 meters of the sea, the water is alive with motion. Microscopic plants called phytoplankton drift in vast blooms, turning the water shades of green and blue. They are the foundation of nearly all ocean life. Tiny organisms no larger than a grain of sand, photosynthesizing and multiplying in numbers that stagger the imagination. But their lives are fleeting. Within days or weeks, most will die, and when they do, they will begin a journey that connects the surface world to the deepest trenches on Earth. What happens when these microscopic lives end? They do not simply vanish. Each dead phytoplankton cell, each discarded shell from a tiny zooplankton, each fragment of a larger creature begins to sink. At first, the descent is almost imperceptible. The particles are so small, so light, that they drift more than fall. But gravity is patient, and it never stops pulling. Imagine standing in this sunlit water and watching a single flake of organic matter begin its downward journey. You would barely notice it moving. Yet over hours and days, it will travel deeper than any human could dive without protection. But marine snow is not just dead phytoplankton. It is a collection, an accumulation of everything that once lived or was produced by life in the surface waters. Bits of jellyfish mucus that drift away when these creatures pulse through the water. Fecal pellets from tiny copepods and krill, surprisingly dense packages that sink faster than you might expect. Fragments of larger fish that died and began to decompose. Even discarded houses from larvaceans, delicate creatures that build mucus nets to filter food and then abandon them when they become clogged. All of this material, this biological debris, joins together in a perpetual precipitation that feeds the world below. You might wonder how scientists even discovered this phenomenon. After all, individual particles are nearly invisible to the naked eye. The answer came through patience and careful observation. Researchers lowering instruments into the deep ocean noticed that their cameras and collection devices would capture strange, drifting material. When they examined it closely, they realized they were seeing something profound. This was not pollution or debris from human activity. This was the ocean's own recycling system, a mechanism that has existed for hundreds of millions of years. They called it marine snow because of how it appeared in their lights, like a gentle snowfall in an alien world. Take a moment to appreciate the scale of what we are about to witness. The ocean covers more than 70% of our planet's surface. In every square meter of this vast expanse, marine snow is falling right now. If you could see it all at once, you would witness a perpetual storm of organic matter descending through layer after layer of water. Some estimates suggest that billions of tons of this material sink into the deep ocean every year. It is one of the largest migrations of matter on Earth, and yet it happens in near total silence, hidden from human eyes beneath the waves. Not all marine snow sinks at the same speed. Some particles are denser and fall relatively quickly, reaching the seafloor in days or weeks. Others are so light and delicate that their journey might take months. Many particles never reach the bottom at all. They are consumed by creatures in the middle depths, broken down by bacteria or dissolved back into the water. Only a fraction of the organic matter that begins its descent will actually reach the abyssal plains. But that fraction is enough. It is enough to sustain entire ecosystems that exist in perpetual darkness, ecosystems that have never known the warmth of the sun. Before we descend with the snow, let us linger here in the surface waters for just a moment longer. Feel the warmth of the sun above you. Watch the play of light on the rippling surface. Here, life is abundant and energetic. Fish dart through the water. Dolphins leap and dive. Seabirds plunge from the sky to catch their prey. But beneath this vibrant world lies another realm entirely, one that is cold, dark, and still. A realm where the only connection to the life above is the gentle, endless fall of marine snow. Are you ready to leave the light behind? Then let us begin our descent into the twilight. As we prepare to follow the snow downward, consider this remarkable fact. The organic carbon contained in marine snow plays a crucial role in regulating Earth's climate. When this carbon sinks to the deep ocean, it is effectively removed from the atmosphere for hundreds or even thousands of years. This process, known as the biological pump, helps to moderate the amount of carbon dioxide in our air. Without marine snow, without this constant rain of organic matter into the depths, our planet would be a very different place. The surface waters would be richer in nutrients, but the atmosphere would hold more heat. In a very real sense, the creatures of the deep sea and the snow that feeds them help to keep our world in balance. We are sinking now, you and I, following a cluster of marine snow particles as they drift away from the surface. Already, the light is beginning to change. The brilliant blues and greens of the surface zone are fading, replaced by deeper shades of azure and cobalt. We are passing through the layer where most human activity occurs, the realm of swimmers and snorkelers, of shallow coral reefs and kelp forests. But we are not stopping here. Our destination lies far below. Can you feel the temperature dropping? The water is noticeably cooler now, and the sunlight, though still present, is softer and less direct than it was just minutes ago. At around 50 meters depth, something begins to happen to the marine snow. The particles that were drifting individually start to aggregate, clumping together into larger flakes. This process is facilitated by sticky organic compounds, substances produced by bacteria and algae that act like a biological glue. As the flakes grow larger, they sink faster. What was once a leisurely drift becomes a more purposeful fall. These aggregated particles can be several millimeters across, large enough to see with the naked eye if you were swimming here. They tumble through the water like tiny snowflakes in a winter storm, each one carrying a cargo of nutrients and energy toward the waiting darkness below. The creatures of this depth are aware of the marine snow. Small fish and jellyfish intercept the falling particles, filtering them from the water or picking them off one by one. Copepods, tiny crustaceans no bigger than a grain of rice, swarm through the water in search of these nutritious morsels. They are the gardeners of the mesopelagic zone, harvesting the bounty that falls from above. But they cannot consume it all. For every particle eaten here, dozens more continue their downward journey. Watch how a translucent jellyfish extends its tentacles into the path of the snow, passively collecting food as it drifts. There is no urgency in its movements, only a patient acceptance of what the ocean provides. We have reached a depth of about 100 meters now, and the change in the environment is profound. The light here is only about 1% as bright as it was at the surface. Colors are beginning to disappear. Reds and oranges are the first to vanish, absorbed by the water above. Soon, only blues and grays will remain. The marine snow continues its fall, but now it is illuminated only by the faint glow of the sun and the occasional flash of bioluminescence from a passing creature. If you look closely, you might see that some of the particles themselves are glowing, inhabited by bioluminescent bacteria that emit a soft, ethereal light as they decompose their organic substrate. This is the edge of the photic zone, the boundary where photosynthesis can no longer occur. Below this depth, plants cannot survive because there is not enough light to power their growth. We are about to enter a realm that depends entirely on the generosity of the surface world. Every calorie of energy in the depths below must come from above, delivered by marine snow or by the larger creatures that migrate up and down through the water column. It is a one-way flow. And we are watching that gift in motion, particle by particle, flake by flake. Descending with the marine snow, you begin to notice something curious. The particles are not all falling in straight lines. Water currents, invisible to the eye, push them sideways, creating swirling patterns. A particle that started its journey directly above one point on the seafloor thousands of meters below might land kilometers away from that spot. The ocean is not a still pond, but a dynamic, three-dimensional space where currents flow in complex patterns. The marine snow does not simply drop straight down like rain in still air. It dances and spirals, following the whims of the moving water, spreading the nutrients from the surface across vast areas of the deep ocean floor. At 150 meters, we pause to observe a fascinating phenomenon. A small fish, a lanternfish with glowing photophores along its sides, is making its way upward through the water. It is part of the largest migration on Earth, a daily journey undertaken by countless creatures who rise to the surface at night to feed and then descend back to the depths during the day. These vertical migrators are another way that energy is transported from the surface to the deep. They eat in the rich waters above and then excrete waste in the dark waters below, supplementing the marine snow with their own contribution to the biological pump. Everything in the ocean is connected through these flows of matter and energy. As we continue downward, leaving the 200-meter mark behind, the last remnants of surface light are fading away. We are entering true twilight now, the mesopelagic zone, where the ocean becomes a place of shadows and subtle movements. The marine snow is still falling around us, a constant presence in every direction. Some flakes are large and fall quickly. Others are barely visible, drifting so slowly that they seem almost suspended in the water. Together, they create a mesmerizing spectacle, a silent storm that has no beginning and no end. Take a deep breath and let yourself sink deeper with the snow. There is so much more to see in the darkness ahead. Welcome to the mesopelagic zone, the twilight realm that extends from about 200 to 1,000 meters below the surface. Here, the sun is nothing more than a faint memory, a dim glow that barely penetrates the water above. Your eyes would struggle to see anything in this environment, but you would not be in complete darkness. Not yet. This is a place of perpetual dusk, where creatures have evolved to see in light levels that seem impossibly low. And the marine snow continues its descent through this twilight world, feeding the hunters and scavengers that drift through the gloom. The creatures here are unlike anything you would encounter near the surface. Many are translucent, their bodies nearly invisible except for their eyes and internal organs. Others are covered in bioluminescent organs, creating their own light to hunt, communicate, or camouflage themselves against the faint glow from above. A hatchetfish swims past, its body flattened and blade-like, its underside studded with lights that match the intensity of the background light, making it invisible to predators below. It pauses occasionally to snap up a particle of marine snow, its large eyes perfectly adapted to spot these tiny morsels in the dim light. At 300 meters depth, we are now in near total darkness to human eyes. But for the creatures that live here, this is normal. This is home. They do not miss the sun because they have never known it. Instead, they rely on other senses and on their ability to produce light. The marine snow around us is beginning to show more signs of bioluminescence. Bacteria that colonize the particles glow with a steady, cold light, turning each flake into a tiny beacon. These glowing particles attract small creatures, which in turn attract larger predators. The marine snow is not just food. It is also a lure, a way for the deep ocean to concentrate life in a vast, dark emptiness. Here in the Twilight Zone, marine snow plays another crucial role. It provides surfaces for bacteria to colonize and grow. These bacteria are not just passive decomposers. They are active players in the ocean's chemistry, breaking down complex organic molecules into simpler compounds that can be used by other organisms. As the snow falls, it carries these bacterial colonies with it, spreading microorganisms throughout the water column. In a sense, each particle of marine snow is a tiny traveling ecosystem, a microhabitat supporting dozens or even hundreds of microscopic lives. As we pass through 400 meters, the marine snow around us seems to thin out. This is not because less snow is falling from above. Rather, it is because the creatures of the Twilight Zone are very efficient at intercepting and consuming it. This zone is sometimes called the ocean's twilight belt, and it contains some of the highest biomass of fish on Earth. Most of these fish are small, but their numbers are staggering. They form vast, diffuse clouds that extend for kilometers, each individual waiting patiently for the next flake of marine snow to drift within reach. Together, they filter enormous quantities of organic matter from the water, preventing it from reaching the deeper depths. But not all the snow is consumed here. Look carefully and you will see that some particles are sinking too quickly to be caught. These are the dense aggregates, the fecal pellets from larger creatures, the pieces that have already been processed through digestive systems above. They fall at speeds that can exceed 100 meters per day, racing through the Twilight Zone on their way to the abyss. These fast, sinking particles are the express delivery system of the ocean, transporting carbon and nutrients to the deepest reaches in a matter of weeks rather than months. They are the snowflakes that will reach the very bottom of the world. At 600 meters, we encounter something unexpected. A massive jellyfish, several meters across, is drifting through the water like a living parachute. Its body is covered in sticky mucus that traps marine snow particles. As it moves, it collects these particles on its surface, concentrating them into patches that will eventually be consumed by its trailing tentacles or by other creatures that follow in its wake. This jellyfish is both a predator and a platform, a mobile reef that provides habitat for smaller organisms. Even in the deep ocean, cooperation and interdependence are the rules of survival. We are approaching the bottom of the mesopelagic zone now, descending past 800 and then 900 meters. The water here is cold, just a few degrees above freezing, and the pressure is building. At this depth, the weight of the water above us is nearly 90 times greater than the atmospheric pressure at sea level. But the marine snow is unbothered by these conditions. It continues to fall, just as it has fallen through every layer above. Ahead of us lies an even darker realm, a place where the faintest hint of sunlight never penetrates. Are you ready to leave the twilight behind and enter the midnight zone? Then let us descend once more into the deepening dark. We have crossed the threshold. We are now in the bathypelagic zone, the midnight zone, which extends from 1,000 to 4,000 meters below the surface. Here, no sunlight penetrates at all. None. If you could somehow survive at this depth without any artificial light source, you would see only the bioluminescence of living creatures and the occasional glow of marine snow particles colonized by luminous bacteria. The darkness is absolute and eternal. And yet, life persists. In fact, life thrives in ways that would astonish you. The marine snow continues its descent through this lightless realm, providing the foundation for an ecosystem that has existed in darkness since the dawn of complex life on Earth. The creatures of the Midnight Zone are among the strangest on our planet. An anglerfish drifts past, its enormous mouth filled with needle-like teeth, a bioluminescent lure dangling from a spine on its head. It uses this lure to attract prey in the darkness, mimicking the appearance of a glowing particle of marine snow or a small luminous organism. When a curious victim comes to investigate, the anglerfish strikes with lightning speed. The marine snow here is not just food. It is also camouflage, a way for predators to hide their true nature until it is too late for their prey to escape. At 1,200 meters, the marine snow seems paradoxically more visible than it was in the Twilight Zone. This is because your eyes have adjusted to the darkness, and the bioluminescence of the particles stands out more clearly. Each glowing flake creates a tiny sphere of light as it falls, a miniature star in an ocean of night. If you could time-lapse this descent, you would see that the marine snow creates rivers and streams of light flowing downward through the water, concentrating in some areas and spreading out in others, following currents that are completely invisible but which shape the distribution of life throughout the deep. The organisms that feed on marine snow at this depth have developed specialized adaptations. Many have large, sensitive mouths that can detect and capture even the smallest particles. Others have abandoned active hunting altogether and simply extend feeding structures into the water, waiting for the snow to drift into their grasp. A siphonophore, a colonial organism that can stretch for tens of meters, hangs vertically in the water like a living fishing line. Its stinging tentacles trail downward, intercepting marine snow and any small creatures that are attracted to it. This is a patient way of life, suited to an environment where food is scarce and energy must be conserved. We are at 1,500 meters now, and something remarkable is happening. The marine snow is beginning to accumulate on structures in the water, not on the seafloor, which is still thousands of meters below us, but on biological surfaces. A massive Lavatian house, abandoned by its builder hours or days ago, drifts slowly downward like a ghostly net. It is covered in trapped marine snow, so much that it looks like a translucent snowball. Eventually, this structure will either be consumed by a scavenger or will sink to the bottom, delivering a bonanza of organic matter to the creatures that live on the abyssal plains. These abandoned houses are an important part of how organic matter reaches the deep sea. As we descend through 2,000 meters, the nature of the marine snow begins to change again. Much of what reaches this depth has already been partially decomposed by bacteria. The organic matter is more broken down, more uniform in composition. The particles are smaller on average because the larger, more nutritious aggregates have been consumed in the zones above. What remains is the most persistent material, the bits that are harder for organisms to digest and for bacteria to break down. This is the marine snow that will reach the deepest parts of the ocean, carrying with it the final traces of surface productivity into the abyss. The Midnight Zone is sometimes called the largest habitat on Earth. It contains more living space than all the terrestrial habitats combined, more volume than all the world's forests, grasslands, and deserts put together. And throughout this vast space, marine snow is falling, always falling. Right now, as you listen to these words, trillions upon trillions of particles are drifting downward through the darkness, each one carrying nutrients and energy to the creatures below. This is not a dramatic process. There are no sudden changes, no visible events. Just a slow, steady rain of organic matter that has continued without pause for millions of years. At 3,000 meters depth, we pause to reflect on the journey so far. We have descended from the bright, warm surface through layers of increasing darkness and cold. We have watched the marine snow change from fresh organic matter to increasingly decomposed debris. We have seen creatures adapted to every depth, each playing their role in processing and consuming the falling particles. And yet, we are still not at the bottom. The deepest parts of the ocean lie another 1,000 meters below us, and beyond that, there are trenches that descend even further. The marine snow has further to fall, and we will follow it. Deeper still into the heart of the abyss, we are entering the abyssopelagic zone now, the realm of the abyss. This zone extends from 4,000 meters down to the ocean floor, which in most places lies at around 6,000 meters depth. The pressure here is crushing, more than 400 times the atmospheric pressure at sea level. The temperature hovers just above freezing. No plant has ever grown here. No ray of sunlight has ever illuminated these waters. And yet, the marine snow continues to fall, bringing life-sustaining nutrients from the distant surface world. We are approaching the bottom of the world, where the falling snow will finally complete its journey. The creatures that live at these depths are sparse and scattered. Food is so scarce that animals must be extremely efficient with their energy. Many have slow metabolisms, moving little and growing slowly over decades or even centuries. A giant isopod, a crustacean related to the pill bugs you might find in your garden but grown to the size of a football, crawls across the seafloor far below us. It is a scavenger, feeding on whatever organic matter settles within its reach. For this creature and others like it, marine snow is not just a source of food. It is the only source of food, the only link to the energy of the sun that shines so impossibly far above. At 4,500 meters, we can begin to sense the proximity of the seafloor. The water here carries a faint taste of sediment, particles stirred up by bottom currents and by the movements of seafloor creatures. The marine snow around us is thinner now than it was in the zones above. So much has been consumed during the long descent that only a small fraction remains. But what does remain will make a difference to the creatures waiting below. In the deep ocean, every particle matters. A single flake of marine snow might provide enough nutrition to sustain a small organism for days. And then, suddenly, we see it. The seafloor. After hours or days of falling through open water, the marine snow particles are approaching a solid surface. The abyssal plains stretch out below us, vast expanses of soft sediment that cover more than half of the Earth's surface. This is the most common environment on our planet, and yet it is one of the least explored and least understood. The sediment here is made up of countless layers of marine snow that have settled over millions of years, each layer representing a chapter in the history of life in the ocean above. We are about to witness the end of the fall and the beginning of a new phase in the cycle of marine snow. The landing is gentle. A particle of marine snow that has fallen thousands of meters touches down on the sediment with no fanfare, no disturbance. It simply comes to rest, joining billions of other particles that have settled here before it. But its journey is not over. Within hours or days, this particle will be discovered by a seafloor creature or will be colonized by sediment-dwelling bacteria. Its organic matter will be broken down and the nutrients it contains will be released into the sediment or back into the water column. In time, some of these nutrients might even make their way back to the surface, carried by deep ocean currents to support new blooms of phytoplankton. The cycle continues. Look around at this landscape. The abyssal plains are not entirely flat. There are gentle hills and valleys, the result of sediment deposition patterns over millions of years. Here and there you might see a rock or a piece of wood, rare hard surfaces in a world of soft mud. These objects become oases of life, attracting creatures that need a solid substrate to attach to. But most of the seafloor is bare sediment, populated only by the organisms that can burrow through it or crawl across its surface. And everywhere, constantly, marine snow is settling. The rain never stops. Even here, at the bottom of the world, the connection to the surface remains unbroken. The sediment here is soft and fluffy, recently deposited and not yet compacted by the weight of additional layers. If you could run your hand through it, it would feel almost like flour. This surface layer is called the bioturbated zone, a region where organisms actively mix the sediment through their burrowing and feeding activities. Worms tunnel through the mud, filtering out organic particles. Sea cucumbers plow across the surface, leaving trails behind them as they process sediment in search of food. All of this activity is powered by marine snow. Without the constant input of organic matter from above, this sediment would be lifeless and still. There is something profoundly peaceful about this place. The darkness is complete. The water is nearly still. The only movements are slow and deliberate. A xenophyophore, one of the largest single-celled organisms on Earth, sits motionless on the sediment, its delicate structure built from particles of sediment and marine snow cemented together. It has been growing in this spot for decades, slowly accumulating mass. Nearby, a brittle star extends its arms across the surface, waiting to detect the vibrations of settling marine snow particles. This is a world where patience is not just a virtue, but a necessity. Time moves differently here, measured not in seconds or minutes, but in the slow accumulation of organic matter from above. Let us spend some time here on the abyssal plains, observing the creatures that depend on marine snow for their survival. These organisms are among the most specialized on Earth, adapted to extract energy from the sparse and intermittent supply of food that reaches these depths. Some are deposit feeders, processing large volumes of sediment to extract the small amount of organic matter it contains. Others are suspension feeders, capturing particles directly from the water as they settle. And a few are opportunistic scavengers, waiting for the rare bonanzas that occasionally fall from above. Together, these creatures form a functioning ecosystem in what might seem like the most inhospitable environment imaginable. Sea cucumbers are among the most abundant large animals on the abyssal plains. They move slowly across the sediment, using modified tube feet to push mud into their mouths. Inside their digestive systems, bacteria help break down the organic matter in the sediment, extracting nutrients that the sea cucumber can absorb. What passes through is expelled behind them as a trail of processed sediment. In some areas, sea cucumbers are so numerous that they process the entire top layer of sediment multiple times per year. They are the earthworms of the deep ocean, performing the essential service of recycling organic matter and mixing the sediment. Not all creatures on the seafloor move across it. Some have chosen to stand still and let the food come to them. Stalked crinoids, relatives of starfish and sea urchins, attach themselves to the sediment with a long stem and extend feathery arms into the water column above. These arms are covered in sticky tube feet that trap particles of marine snow as they drift past. Periodically, the crinoid bends its arms toward its mouth, transferring the captured food for digestion. It is a simple but effective strategy, one that has allowed crinoids to survive virtually unchanged for hundreds of millions of years. They are living fossils, witnesses to the entire history of complex life in the deep ocean. Polychaete worms are everywhere in the sediment, though you would hardly notice them unless you looked closely. These segmented worms build tubes or burrow through the mud, extending feeding appendages to capture marine snow or to graze on the bacteria that grow on settled particles. Some species create elaborate branching tubes that rise above the sediment surface, maximizing their access to settling food. Others remain buried, relying on currents to bring food down into their burrows. There are thousands of species of polychaetes in the deep ocean, each adapted to a slightly different niche, each playing its part in processing the rain of organic matter from above. Occasionally, something larger arrives. A dead fish, a whalebone, a waterlogged piece of wood. These are called food falls, and they create temporary hotspots of activity on the otherwise uniform seafloor. Within hours of a large carcass reaching the bottom, scavengers begin to gather. Hagfish emerge from the sediment, their eel-like bodies writhing as they burrow into the flesh. Amphipods swarm over the surface, stripping away tissue. The sudden influx of organic matter is like a feast after months of famine. But these events are rare. Most of the time, the creatures of the abyss must rely on the slow, steady supply of marine snow to sustain them. Even on the abyssal plains, there are predators. They are not the fast, aggressive hunters you would find near the surface. Instead, they are patient ambush predators or slow-moving stalkers. A sea spider, all legs and no body to speak of, picks its way across the sediment in slow motion. It is searching for small worms or crustaceans hidden in the mud. When it finds prey, it uses its proboscis to pierce the victim and suck out its bodily fluids. This predator is indirectly supported by marine snow because the creatures it hunts depend on marine snow for food. In the deep ocean, every food chain ultimately traces back to the falling particles from above. The sediment itself is alive. If you could see at the microscopic scale, you would discover that the top layer of mud is teeming with bacteria and other microorganisms. These bacteria are the true recyclers of the deep ocean. They break down the complex organic molecules in marine snow into simpler compounds that can be used by other organisms or that dissolve back into the water. Without bacteria, marine snow would simply pile up on the seafloor, burying the bottom in a thick layer of undecayed organic matter. But bacteria ensure that the nutrients are released and made available again, completing the cycle that connects the surface ocean to the abyss. As we observe this ecosystem, consider how finely balanced it is. The creatures here have evolved over millions of years to extract every possible calorie from the limited food supply. They grow slowly, reproduce infrequently, and live long lives. Some sea cucumbers may live for over a century. Some tube worms may survive for decades without moving from their spot. This is not a dynamic ecosystem with rapid turnover. It is a stable, ancient community that changes on geological timescales. And yet, it is vulnerable. Any disruption to the supply of marine snow from above, whether from climate change or from human activities, could have profound effects on these deep-sea communities. There are places on Earth where the ocean floor descends even deeper than the abyssal plains. These are the Hadal trenches, named after Hades, the Greek god of the underworld. They are the deepest points in the ocean, plunging down to depths of 7, 8, or even 11 kilometers below the surface. The Mariana Trench, the deepest of them all, reaches nearly 11,000 meters at its lowest point. And even here, unbelievably, marine snow continues to fall. We will follow it now into these ultimate depths to see where the journey truly ends and what awaits at the very bottom of the world. The conditions in the Hadal trenches are extreme beyond imagination. The pressure at the bottom of the Mariana Trench is over 1,000 times greater than atmospheric pressure at sea level. If you could place a lead weight there, the pressure would actually deform the metal. The temperature is just above freezing. The darkness is absolute. And yet, when scientists send cameras and sampling devices to these depths, they find life. Not just bacteria, but amphipods, snailfish, and sea cucumbers, all feeding on the marine snow that manages to reach these depths. Life, it seems, is unstoppable. Given even the slightest source of energy, it will find a way. The marine snow that reaches the Hadal trenches has been falling for weeks or even months. It has passed through every zone of the ocean, been processed and reprocessed by countless organisms, and has survived the long journey to the bottom. By the time it arrives here, it is highly degraded, containing only the most resistant organic compounds. And yet, the creatures of the Hadal zone have evolved to digest even these recalcitrant materials. Hadal amphipods have powerful enzymes that can break down molecules that would be indigestible to most other organisms. They have become specialists in extracting energy from the most difficult food sources. Some trenches act as funnels, concentrating marine snow from a wide area into a narrow valley. This creates areas of relatively high food availability compared to the surrounding abyssal plains. In these spots, the density of life can be surprisingly high for such extreme depths. Sea cucumbers cluster together, their feeding tracts crisscrossing the sediment. Bacterial mats grow in thick layers where organic matter accumulates. Even in the Hadal zone, there are oases and deserts, areas of abundance and areas of scarcity. The distribution of marine snow determines where life can thrive, even at the bottom of the deepest trenches on Earth. The Hadal snailfish is one of the most remarkable creatures in the ocean. It has been found at depths exceeding 8,000 meters, making it one of the deepest living fish in the world. Its body is soft and gelatinous, an adaptation to the extreme pressure. It lacks scales and has small, almost useless eyes. But it is a capable predator, feeding on amphipods and other small creatures that in turn feed on marine snow. Even at these depths, there is a food web, a hierarchy of organisms consuming and being consumed. And at the base of this web, as always, is the marine snow falling from the world above. Some of the organic matter that reaches the Hadal depths is not marine snow in the traditional sense. It is the remains of larger organisms that have died and sunk intact. Whale carcasses, for instance, can take decades to be fully consumed. They support entire ecosystems during their decay, hosting species found nowhere else on Earth. But between these rare bonanzas, the creatures of the trenches must rely on the steady but sparse supply of marine snow. It is a feast or famine existence, requiring extreme adaptations and patience. The creatures here may go weeks or months between substantial meals, surviving on the smallest particles during the lean times. The sediment in the Hadal trenches is different from that on the abyssal plains. It can be meters or even tens of meters thick in places where it has accumulated over millions of years. This sediment is a record of the ocean above, layer upon layer of settled marine snow, each layer representing a different era in Earth's history. By drilling into these sediments, scientists can read the history of the ocean's productivity, of climate changes, of mass extinctions and recoveries. The Hadal depths are not just the deepest places on Earth. They are also archives, preserving information about our planet's past in their accumulated layers of marine snow. We have reached the ultimate depths. There is nowhere deeper to go. The marine snow that falls to the bottom of the Hadal trenches has completed the longest journey any organic particle can make in the ocean. From the bright, warm surface where it began as living tissue, through thousands of meters of water, through zones of light and darkness, through communities of organisms that processed and transformed it, it has finally come to rest in the deepest, darkest place on our planet. And here, even here, it will not go to waste. It will be consumed, decomposed, and recycled, its nutrients eventually making their way back into the ocean's circulation. The cycle is complete, yet it never truly ends. The story of marine snow does not end at the bottom of the ocean. In fact, in many ways, it is just beginning a new chapter. The nutrients released by the decomposition of marine snow in the deep ocean do not remain trapped there forever. Over time, scales of hundreds or thousands of years, these nutrients are carried back toward the surface by ocean circulation. Deep water currents move slowly across the seafloor, gradually transporting water from the poles toward the equator and from the depths toward the shallows. Eventually, through a process called upwelling, this nutrient-rich deep water returns to the surface, completing a cycle that connects every part of the ocean. Upwelling zones are some of the most productive regions in the ocean. When deep, nutrient-rich water rises to the sunlit surface, it fuels massive blooms of phytoplankton. These blooms support abundant populations of fish and other marine life. The nutrients that support these blooms include nitrogen, phosphorus, and iron that were released from marine snow in the deep ocean, sometimes decades or centuries earlier. In this way, the death of microscopic organisms in one time and place supports the flourishing of life in another. The ocean is not a collection of separate ecosystems. It is a single, interconnected system, and marine snow is the thread that binds it all together. Consider the journey of a single atom of nitrogen. It begins in a molecule of protein in a phytoplankton cell near the ocean surface. When that cell dies, the nitrogen becomes part of marine snow and begins to sink. It may pass through the digestive systems of several organisms on its way down, each time being incorporated into new tissue and then released again. Eventually, it reaches the deep ocean, where bacteria break down the last of the organic matter and release the nitrogen as a dissolved ion. This nitrogen may spend 1,000 years in the deep ocean before being carried by currents to an upwelling zone. There, it returns to the surface and is taken up by a new phytoplankton cell, beginning the cycle again. Not all the carbon in marine snow returns to the surface. Some of it becomes buried in sediment, where it may remain for millions of years. Over geological time, this buried organic carbon can be transformed into fossil fuels like oil and natural gas. The coal, oil, and gas that power our modern civilization are, in a sense, ancient marine snow. They are the compressed, altered remains of organisms that lived and died in ancient seas, their bodies sinking to the seafloor and being buried before they could fully decompose. When we burn these fuels, we are releasing carbon that was removed from the atmosphere millions of years ago by the biological pump. The burial of carbon in deep-sea sediments is one of Earth's most important climate regulation mechanisms. By removing carbon dioxide from the atmosphere and storing it in the ocean depths, the biological pump helps to keep our planet's temperature in a range that supports complex life. If marine snow did not sink, if all organic matter were decomposed in the surface waters and its carbon released back to the atmosphere immediately, Earth would be much warmer than it is. The deep ocean is a carbon reservoir, and marine snow is the mechanism that fills it. This has been happening for hundreds of millions of years, shaping the evolution of our planet's climate and making Earth habitable for creatures like us. Climate change is affecting the biological pump in ways we are only beginning to understand. Warming surface waters are becoming more stratified, meaning that the layers of different temperature and density are becoming more distinct. This stratification can reduce the amount of nutrients that upwell from the deep ocean, potentially decreasing the productivity of phytoplankton blooms. At the same time, changes in ocean chemistry due to increasing carbon dioxide levels may affect how much organic matter sinks as marine snow versus being decomposed in surface waters. These changes could alter the amount of carbon that the ocean can store, with implications for the future of our climate. Understanding marine snow is not just an academic exercise. It has real implications for how we manage our impact on the ocean and on the planet as a whole. The deep-sea communities that depend on marine snow are threatened by activities like deep-sea mining, which could disturb the sediments where these organisms live. Bottom trawling, a fishing method that drags nets across the seafloor, can destroy the delicate structures built by filter feeders and can resuspend settled marine snow, altering the food supply for deep-sea creatures. As we continue to explore and exploit the deep ocean, we must consider how our actions might affect the reign of marine snow and the ecosystems it supports. The cycle of marine snow reminds us that the ocean is not separate from the rest of Earth's systems. The surface and the deep are connected. The past and the present are linked. The tiny and the vast are part of the same story. When you eat a piece of fish caught in a coastal upwelling zone, you are consuming energy that may have been captured by phytoplankton nourished by nutrients from marine snow that fell to the deep ocean decades ago. When you breathe, you are inhaling oxygen produced by phytoplankton, whose growth is supported by the cycling of nutrients through the depths. You are part of this cycle, connected to the falling snow in ways both direct and indirect. How do scientists study something as ephemeral and widespread as marine snow? It is not easy. The particles are small, dispersed throughout the vast volume of the ocean, and constantly changing as they sink and decompose. But researchers have developed ingenious methods to observe and quantify this phenomenon. Some of these methods involve lowering cameras and light sensors into the deep ocean to observe marine snow directly. Others involve collecting samples of sinking particles using traps that are deployed for weeks or months at a time. Still others involve measuring the chemical composition of seawater at different depths to infer how much organic matter is being transported downward. Sediment traps are one of the most important tools for studying marine snow. These devices are essentially large funnels that are suspended in the water column. As particles sink, some of them fall into the funnel and are collected in bottles at the bottom. By analyzing what accumulates in these traps over time, scientists can measure how much organic matter is sinking at different depths and in different parts of the ocean. They can also examine the composition of the material, identifying the types of organisms it came from and measuring the chemical elements it contains. Each sediment trap deployment provides a snapshot of the rain of marine snow at a particular time and place. Underwater cameras have revealed much about the diversity and abundance of marine snow particles. Modern cameras can be equipped with lasers or LED lights that illuminate a volume of water in front of the lens. Computer algorithms then analyze the images, identifying and counting individual particles, measuring their size, and sometimes even determining their composition based on their shape and reflectivity. These imaging systems can be deployed on stationary moorings, on autonomous underwater vehicles, or on remotely operated vehicles that scientists control from research ships. They have shown us that marine snow is more variable and more complex than scientists initially imagined. Satellite observations provide a complementary perspective on marine snow, though they cannot see the particles directly. Satellites measure the color of the ocean surface, which is determined in large part by the concentration of phytoplankton. Areas with high phytoplankton productivity are likely to produce more marine snow when those organisms die. By tracking phytoplankton blooms from space over months and years, scientists can estimate how much organic matter is being produced in the surface ocean and how much might be sinking as marine snow. Combined with direct measurements from ships and moorings, satellite data help to build a global picture of the biological pump. Chemical tracers provide another way to study the movement of marine snow through the ocean. Scientists measure the concentrations of elements like carbon, nitrogen, and phosphorus in seawater at different depths. They also measure the isotopic composition of these elements, which can reveal where they came from and how they have been processed by organisms. By comparing the chemistry of surface water with that of deep water, researchers can calculate how efficiently the biological pump is transporting organic matter to the depths. These measurements have shown that the efficiency of the pump varies from place to place and from season to season, influenced by factors like temperature, nutrient availability, and the composition of the phytoplankton community. One of the challenges in studying marine snow is that its characteristics can change rapidly. A particle that leaves the surface may be large and fluffy, but by the time it reaches a few hundred meters depth, it may have been broken apart by bacterial activity or by passing through the gut of a zooplankton. The sinking speed of particles can vary by orders of magnitude, from less than 1 meter per day for the smallest flakes to several hundred meters per day for large, dense fecal pellets. This variability makes it difficult to predict how much organic matter will reach the deep ocean and how long it will take to get there. Advances in technology are opening new windows into the world of marine snow. Autonomous underwater vehicles equipped with sophisticated sensors can now patrol the ocean for weeks at a time, collecting data on particle abundance and composition without human intervention. Genetic sequencing allows scientists to identify the species that contribute to marine snow by analyzing the DNA contained in collected samples. Three-dimensional imaging techniques can reconstruct the structure of individual aggregates in incredible detail, revealing how different types of organic matter and minerals are bound together. Each new tool and technique adds to our understanding of this fundamental oceanographic process. Despite decades of research, there is still much we do not know about marine snow. How will climate change affect its production and sinking speed? What role do viruses play in the breakdown of organic matter? How important are rare but large particles compared to the more numerous small particles? Are there undiscovered organisms in the deep ocean that depend on marine snow in ways we have not yet observed? These questions drive ongoing research efforts around the world. Every expedition to the deep ocean, every new dataset from a sediment trap or an imaging system brings us closer to understanding the full story of marine snow and its role in shaping our planet. We have journeyed from the surface to the deepest trenches, following marine snow through every zone of the ocean. We have seen it produced in the sunlit waters, transformed as it falls, and consumed in the darkness of the abyss. But what does this mean for us as human beings living our lives on land? Why should you care about particles falling through the ocean that you will never see with your own eyes? The answer is that marine snow connects us to the ocean in profound and often invisible ways. It is part of the machinery that maintains the habitability of our planet, and understanding it helps us understand our place in the natural world. Marine snow is a reminder that the ocean is not just a vast body of water. It is a living system, a dynamic environment where matter and energy are constantly cycling between different forms and different places. The plankton that produce marine snow are responsible for producing about half of the oxygen in Earth's atmosphere. Every other breath you take comes from the ocean. When those plankton die and sink as marine snow, they take carbon with them, carbon that would otherwise remain in the atmosphere as carbon dioxide. In this way, the falling snow helps to regulate Earth's climate, making our world more stable and more hospitable to life. The study of marine snow also teaches us about interconnectedness. In our daily lives, it is easy to think of ourselves as separate from nature, insulated by our technologies and our cities. But marine snow shows us that separation is an illusion. The nitrogen in the proteins in your body may have cycled through the ocean dozens of times over millions of years. The carbon atoms that make up your cells were once part of ancient organisms whose remains became marine snow in prehistoric seas. You are not separate from the ocean. You are made of the ocean, of the same atoms and molecules that have been cycling through Earth's systems since long before humans existed. Marine snow also offers us a different way of thinking about time. In our fast-paced world, we often focus on the immediate, on what is happening right now or what will happen in the next few days or weeks. But marine snow operates on timescales that range from hours to millennia. A particle that forms today may reach the seafloor in a week or a month. The nutrients it releases may return to the surface in 100 years or 1,000. The carbon it contains may be buried in sediment for millions of years before being uplifted and weathered, returning to the atmosphere. Contemplating these vast timescales can be humbling and also liberating, reminding us that we are part of something much larger and longer lasting than ourselves. There is something meditative about the image of marine snow falling endlessly through the ocean. The particles move slowly, steadily, without urgency or deviation. They are not trying to reach the bottom. They are simply falling, pulled by gravity, shaped by currents, transformed by the organisms they encounter. There is a lesson here about acceptance and letting go. Like the marine snow, we are all moving through time, influenced by forces beyond our control, changing and being changed. Perhaps there is wisdom in surrendering to this process, in trusting that even as we fall, we are part of something beautiful and necessary. Marine snow also invites us to consider the value of the unseen and the unnoticed. Most of what happens in the ocean happens far from human eyes. The vast majority of Earth's living space is in the deep sea, where no human has ever been without the protection of a submersible. The organisms that live there, the processes that shape the ocean, the connections that bind the surface to the abyss, all of this exists and functions without our awareness or our intervention. Marine snow is a reminder that the world does not revolve around human perception. There are wonders and complexities in nature that exist entirely independent of whether we see them or understand them. As you lie here tonight, drifting towards sleep, imagine yourself descending with the marine snow. Feel the warmth of the surface waters fading as you sink into the twilight. Watch the light diminish and disappear. Let the darkness embrace you. There is nothing to fear in this darkness. It is not empty. It is full of life, full of movement, full of the slow, patient recycling of matter and energy that has sustained the ocean for eons. You are safe here, cradled by the water, surrounded by the gentle falling snow. Let yourself sink deeper. Let yourself rest. The ocean will hold you. The cycle will continue. Everything is as it should be. When you wake, the ocean will still be there. The marine snow will still be falling. The cycle that connects the surface to the deep, the living to the dead, the past to the future, will still be turning. And you will be part of it. Every breath you take, every meal you eat, every moment you spend in this world, you are participating in the great cycles of matter and energy that shape our planet. You are not separate from nature. You are nature, experiencing itself. And just like the marine snow, you are on a journey, falling through time, changing and being changed, contributing your own small but essential part to the great story of life on Earth. There is an aesthetic dimension to marine snow that we should not overlook. It is objectively beautiful. If you could see it as the deep-sea cameras see it, illuminated against the darkness, you would be struck by its delicate grace. Each particle catches the light differently. Some are translucent, glowing from within with bioluminescence. Others are opaque, casting tiny shadows. They drift and tumble, spinning slowly as they descend, creating patterns that are never the same twice. This is nature's own light show, a performance that has been running continuously for hundreds of millions of years in the darkness where no eye could see it. The aggregates of marine snow can be works of natural sculpture. Under microscopic examination, they reveal intricate structures built from countless smaller pieces held together by sticky organic polymers. There are filaments of cyanobacteria woven through the matrix. There are the geometric shells of diatoms, tiny glass houses abandoned by their occupants. There are fragments of larger organisms, pieces of a puzzle that tells the story of life in the water above. Each aggregate is unique, a microscopic ecosystem with its own architecture and its own community of bacterial inhabitants. They are too small to see with the naked eye, but that does not make them any less remarkable. There is beauty, too, in the patterns that marine snow creates in space and time. In some regions of the ocean, particularly in areas of high productivity, the concentration of sinking particles can be so high that it resembles a literal snowstorm. Imagine a blizzard, but one that never ends, one that has been falling continuously for millions of years. In other regions, the particles are sparse and scattered, falling through the water like occasional snowflakes on a winter day with breaks of clear sky. These patterns reflect the productivity and ecology of the surface waters, creating a kind of map or record of life above that is written in the language of falling particles. The bioluminescence associated with marine snow adds another layer of beauty. The bacteria that colonize the particles often produce light as a byproduct of their metabolism. This light can be blue, green, or sometimes even red, depending on the species of bacteria and the chemicals involved. When disturbed, the particles may flash more brightly, creating sudden points of light in the darkness. A predator moving through the water leaves a trail of glowing particles in its wake. A sinking carcass becomes a meteor of light, attracting scavengers from the surrounding water. The deep ocean is not as dark as you might think. It is filled with living light, and marine snow is often the bearer of that light. Even the act of observing marine snow can be beautiful. The images captured by deep-sea cameras have a haunting, otherworldly quality. They show us a realm that seems to belong to science fiction rather than to our own planet. The particles suspended in the beam of light look like stars, like galaxies, like snow falling in an inverted sky where down is up and up is down. These images remind us that Earth still has mysteries, still has frontiers, still has places that can inspire wonder and awe. The deep ocean is one of the last great wildernesses, and marine snow is one of its most evocative features. There is philosophical beauty in marine snow as well. It represents transformation and continuity, death and life, beginning and ending. Each particle is both an ending, the death of an organism, and a beginning, the start of a journey that will nourish other lives. This duality is present in all of nature, but marine snow makes it visible and tangible. It shows us that death is not the opposite of life, but rather a part of it, a necessary stage in the cycling of matter and energy. In this sense, marine snow is a teacher, offering lessons about impermanence and renewal to those who take the time to observe and reflect. The scientists who study marine snow often speak of it with a kind of reverence. They describe feeling privileged to observe something so fundamental and yet so hidden. They talk about the excitement of seeing their sediment trap samples for the first time, of analyzing the composition of the particles, of piecing together the story that the snow tells about the ocean above. There is a kind of beauty in this scientific curiosity, in the human drive to understand the world around us, even when that world is dark and remote. The study of marine snow is not just about collecting data. It is also about satisfying a deep human need to know, to understand, to connect with the natural world. As we come to the end of our time together, I want to leave you with this thought. Beauty is not always loud or bright or obvious. Oh, sometimes it is quiet. Sometimes it is dark. Sometimes it is so subtle that you have to look very carefully to see it at all. Marine snow is this kind of beauty. It is the beauty of small things, of hidden processes, of cycles that turn slowly over time. It is the beauty of a planet that is alive and dynamic, constantly transforming itself, constantly creating new possibilities out of old materials. If you can find beauty in marine snow, you can find beauty anywhere. The world is full of wonders if you know how to look. We have traveled far together, you and I. From the bright surface of the ocean down through layers of increasing darkness to the very bottom of the world. We have watched marine snow fall through twilight and midnight, through zones of life and zones of seeming emptiness. We have learned about its composition, its transformations, its importance to the planet. But now, as we approach the end of our journey, let us simply be here. Let us stop analyzing and explaining. Let us just sink into the silence and the darkness and feel what it is like to exist in this place. The silence here is not really silence. If you listen carefully, you can hear faint sounds, the creaking and popping of the ocean as temperature and pressure change, the movements of creatures in the sediment below, the rush of your own blood in your ears. But compared to the noise of the surface world, compared to the cacophony of human civilization, this is as close to silence as you are likely to find on Earth. It is a silence that invites contemplation, that creates space for thoughts to settle and for the mind to rest. Embrace this silence. Let it fill you. In the darkness and the silence, your sense of self begins to dissolve. You are no longer a separate being with boundaries and edges. You are part of the water, part of the marine snow, part of the vast, interconnected system of the ocean. This feeling of dissolution can be unsettling at first, but if you allow it, it can also be deeply peaceful. There is a relief in letting go of the constant effort to maintain yourself as a distinct individual. There is rest in simply being part of the flow, part of the cycle, part of the whole. The marine snow continues to fall around you. It has been falling throughout our entire conversation. It will continue to fall long after you have forgotten this moment. There is something comforting about this constancy. In a world where so much changes so quickly, where nothing seems stable or certain, the marine snow is a reminder that some processes continue regardless of human concerns. The ocean does not care about our anxieties or our ambitions. It simply is. It does what it has always done: fall, transform, recycle, continue. Breathe slowly, in and out. With each breath, let yourself sink a little deeper into relaxation. Your body is heavy. Your mind is quiet. There is nowhere you need to be, nothing you need to do. Just be here, in this moment. Feel the gentle pressure of the water supporting you. Feel the cold, but notice that it does not hurt. It is just a sensation, neither good nor bad. Let your awareness expand to include the entire ocean around you, from the surface miles above to the sediment below. You are at the center of everything, and everything is right here with you. The creatures of the deep ocean do not struggle. They do not resist. They have learned to accept the conditions of their environment and to thrive within them. The sea cucumber does not wish it could live in the sunlit surface waters. The anglerfish does not long for warmth and light. They are perfectly suited to where they are, doing what they do. Perhaps there is wisdom in this acceptance. Perhaps we too can learn to be where we are, to accept the conditions of our lives, to stop wishing we were somewhere else or someone else, and simply to be. As you lie here in the darkness, imagine that you are a particle of marine snow yourself. You have let go of the surface. You are falling, slowly and peacefully, through layers of water. You are being transformed by your journey, letting go of what you no longer need, becoming simpler, more essential. And as you fall, you are nourishing others. Your presence, your existence, is a gift to the creatures below. You do not need to try to be useful or important. Simply by being what you are and allowing yourself to fall, you are contributing to the great cycle of life. The journey ends where it must, at the bottom. But even at the bottom, there is no true ending. There is only transformation, only continuation. The marine snow settles into the sediment and becomes part of it. The nutrients are released and begin their long journey back to the surface. The carbon is stored or recycled. Everything becomes something else. Nothing is ever truly lost. And so we reach the bottom of our descent. But it is not an ending. It is simply a transition, a pause before the next phase of the cycle begins. Rest here at the bottom. Rest in the darkness. Rest in the knowledge that you are part of something eternal and beautiful. Let the ocean hold you. Let the silence embrace you. Let yourself drift into the deepest, most peaceful sleep, knowing that when you wake, the world will still be here, still turning, still falling like snow through the darkness, forever and ever. Thank you for descending with me into the deep. Thank you for taking this journey through the darkness, for following the marine snow from the surface to the abyss. I hope you found some peace here, some wonder, some connection to the vast and beautiful planet we call home. If this journey resonated with you, there are more waiting. More mysteries to explore, more wonders to discover, more moments of cosmic calm. Until we meet again, may you carry with you the lesson of the marine snow, that even in falling, there is purpose. That even in darkness, there is beauty. That everything is connected and nothing is ever truly lost. Well,